Hello, I welcome you all to this another interesting screencast. The problem reads that the catapult is used to launch a ball such that it strikes the wall of the building at the maximum height of its trajectory. If it takes 1.5 seconds to travel from A to B, determine the velocity VA at which it was launched, the angle of release theta, and the height h. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So before we start solving this particular problem, let's remind ourselves of the basic equations that we are going to be using. So we have the three basic equations. Velocity, which is the time derivative of position. Acceleration, which is the time derivative of velocity. Then from the two equations, we have this equation A ds v dv. From these equations, we can derive a number of equations, but we'll talk about the most common ones. And these are at acceleration, when acceleration is constant, t equal to 0, and we have s naught and v naught. These are the boundary conditions. And from this, we have the following equations: s is equal to s naught plus v naught t plus half ac t squared. V is equal to v naught plus act, and then we have v squared is equal to v naught squared plus 2ac s minus s naught. Right. So let's choose our reference point. Again, it's really up to us. We can pick this to be a reference point, and once you pick this, then it means this particular height becomes your h minus 3.5. Okay, so for me, I'll not pick that one. I'm going to pick the bottom one. I mean the at the very point, at this particular point, let me show it. So I'm going to pick this as my reference point. Okay, so this will be my reference point. Right, so this is my reference. Therefore, this is my reference. Let me just show some of the other properties that we intend to use. Velocity will have two components, a vertical one and a horizontal one. The horizontal one is constant, and therefore the acceleration is equal to 0. So this is equal to VAX, which is equal to VA cos theta. Then we have this one, VAY, which is equal to VA sine theta. At B, this is the maximum point of the trajectory. So it means that the maximum point here, the vertical component of velocity, because it's the one that is changing, right? It's not constant throughout, it keeps on changing, right? So at this particular point here, B, the maximum point, we expect the vertical component of our velocity to be equal to 0. Okay. So this component is going to be equal to 0. Right? While the horizontal one, this one is the same. Like we said, it's constant throughout. So this one is just equal to I'll just say Vx. This Vx here is equal to Vax. Okay, and then we have this Vy, which is equal to 0. Okay, so let's start with we can start with the horizontal. Okay, horizontal motion, and we know that horizontal motion, the velocity is constant, therefore acceleration is equal to 0. So we are using this equation, this one, s equal to s naught, s equal to s naught plus v naught t plus half ac t squared. Our s in our case is 18. S naught is equal to 0. V naught is equal to VAX, which is equal to VA cos theta. Of course, AC is equal to 0. Therefore, we have 18 equal to VA cos theta, then times the time is already given to us is 1.5 seconds. So this is one equation that we have, 18 equal to 1.5 VA cos theta. Right, let's go to the vertical motion. Mind you, we have three unknowns. Which equation can either go with this one or this one? No, the last one has more unknowns, so let's go with this one. Okay, V final is 0, V naught, AC, and AT. Great. So let's find AC. Convert, so we have 9.81 meters per second squared times 1 foot is approximately equal to 3048 meters. We cancel there. When we divide this, 9.8 divided by 13.3048, this gives us 32.19 feet per second squared. Okay, therefore our AC is just going to be equal to our constant acceleration is acceleration due to gravity, which is a minus 0.19 feet per second squared. Alright, so with this, let's go ahead with that equation. V final Vy, so we are using this equation, V final is equal to V naught plus ACT. V is equal to Vy at the very maximum height of the trajectory, and this is equal to 0. And then V naught is just equal to VAY, which is equal to V sine theta. And our AC is equal to minus 32.19. And our time is 1.5. Therefore, our 0 equal to V sine theta minus 32.19, right, times 1.5. Okay, so we can solve these two equations. Let's solve these two equations. Right, so we have 18 equal to 1.5 VA. Let me start with the 1 for sine. So I'll say I have V sine theta equal to 32.19 times 1.5 equal to 48.285, and divided by we have VA cos theta, then here we have 18 divided by 1.5, right? Therefore this gives us a tan theta is equal to that. So tan theta is equal to just a 48.285 divided by 18 by 1.5. Therefore theta is just going to be equal to 48.285. Let me check it again. 32.19 by 1.5. Okay, divided by 18 divided by 1.5. And then tan inverse of that gives us a 76.04 degrees. So this is the angle. Okay, that's the angle. Once we found the angle, then we can move on to the next steps. We have the angle. We can now find BA. Let's use this equation. Okay, let's find BA. So using that equation, we said 18 is equal to 1.5 BA cos theta. We can simply say VA is now equal to 18 divided by 1.5 cos theta, where theta is equal to 76.04 degrees. Therefore, our VA is just going to be equal to, so we have 18 divided by 1.5 cos 76.04. So we get VA equal to 49.74 feet per second. Let me check this again. 1.5 cos 76.04, 18 divided by answer 49.74. Alright, so let's now find H. We're going to use, I think, this equation. We can also use this, but I'll use the other one. So we are using vertical motion, and we have S equal to S naught plus V naught T plus half AC T square. Our S in our case is H, and S naught is equal to 3.5, and then we have V naught equal to VAY, which is equal to VA sine theta. Okay, and of course theta, we already calculated it, is 76.04, and then VA, we calculated it already, is 49.74. What else? Then we have AC, which is just equal to minus 32.19, and we do have T equal to 1.5. Therefore H is just going to be equal to 3.5 plus VA sine theta, okay, times T minus half 32.19 by T squared. Replacing all those values there, then we can say 3.5 plus 1.5 times 49.74 sine 76.04, okay, minus 0.5 by 32.19 by 1.5 squared. Okay, then we have a 39.69. We have a 39.69 feet. Right. Okay, I think we are done. So let's just outline the final answers. We have the angle. Okay, this is the angle. We have the initial velocity VA, and then we have the value of h. All right, great. I think this is about it, and I hope this video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.